right now is being recorded, right? So that everybody else, those who have missed, may also have the opportunity. So I'm going to share my screen right now. So I'm going to click on share. Okay, just out, I want to hear if you can see my screen. I want to say yes, you to tell me yes, you can see. You tap the microphone, speak, and then
Yes,
you unmute.
I can see.
You can see. Very good. So I think everybody.
Yes, I can. Yeah, yes.
Okay, lovely. Okay.
I can see.
All right. So let me just check. Somebody is waiting to get in before we continue. Let me just see who is there. Dalia had gotten off. Noise. Okay. Right. So let me get back to what I shared. So here is my screen, and there is a video clip. There's a video clip. Somebody's microphone is on. Please now switch off. I'm going to try and play this video. Let's see whether it will open.
Hi, this is Ben Finio with Science Buddies, and this
Are you
video will
hearing?
show you how to use a multimeter. Multimeters come in all shapes and sizes. While professional multimeters can cost hundreds of dollars, if you're a student doing a science project or a hobbyist just tinkering with electronics, a cheaper
Okay.
multimeter
Oh, yeah,
somewhere in the
hearing.
$20 to
You're
$30
hearing
range is
about the
probably all you need.
multimeter. So let's just follow
Most
this video for a
multimeters
short
have similar
time.
features, including a screen that displays the readings, a knob that selects the measurement, and ports where you plug in the probes to take the measurement. In this video, we'll be using this
Yes,
DT830L digital multimeter, which is included in many of our Science Buddies kits. We'll go over how to measure voltage, current, resistance, and do a continuity check. Some of the most common features you'll use on a multimeter. Other multimeters might have more advanced features like the ability to measure capacitance, but we won't be going over those in this video. Most multimeters come with a pair of red and black probes with a plug on one end to go into the multimeter and a pointy probe tip on the other end that you can use to probe circuits. It's convenient to have some alligator clip cables handy, as those can allow you to clip onto the circuit to take measurements so your hands can be free to do other things. There are different types of probe accessories available. For example, these probes have a banana plug on one end to go into the multimeter and an alligator clip directly on the other end instead of a probe tip, so you don't need a separate alligator clip cable. Let's start by looking at our multimeter in a little more detail. There are a lot of symbols on the front that might be kind of overwhelming and confusing at first, but don't worry, we'll go over them one by one as we use them. The main symbols you'll be seeing in this video are V for volts, A for amperes, which is the unit of current, and the capital Greek letter omega, which stands for ohms, or the unit of resistance.
Okay, let me just pause it here. Are you all with me? Are you hearing what's happening?
Yes, sir.
Yes.
Yes.
Okay, so what I was explaining in class, you can see, are you seeing my mouse moving?
Yes, I can do.
Over V, are you seeing that?
Yes, I can
Yeah,
see.
we see.
Good. So what is being explained is that multimeter, this is now the face I had told you people to observe very carefully. So the functions, the V here, that is V direct current. There is A on this side, which is for current, also direct. Okay, so where you see the straight, it is direct. Where you see the wave, V wave, that is alternating current, as I explained. So this is what is being explained here. So just pay close attention and let us continue.
This multimeter has a separate on-off switch that you use to turn the multimeter on and off. More expensive multimeters usually have an auto power off feature that will turn it off automatically after a certain period of inactivity, but this one doesn't, so make sure you remember to turn it off when you're not using it in order to conserve the battery. Now let's look at the ports where we can plug the probes into the multimeter. You'll see that we have three different ports labeled COM, V omega MA, and 10A. COM stands for common. That's where the black probe is going to be plugged in, and we'll usually connect that to the ground or negative side of our circuit. V omega MA stands for volts, ohms, or milliamps. We plug the red probe into this port for most of the measurements we're going to be taking to measure voltage, resistance, or small amounts of current. And then finally, this third one we're not going to use as often. That's for measuring large amounts of current up to about 10 amps. So for now.
Okay, so I would like to just emphasize these three. Sometimes this multimeter, sometimes it has the comb black. Okay, much as here this one has red, but most the modern ones now the comb port is black, so that you can easily know that black goes into the comb port, and then the red that you can vary, red for lower current, voltage, and resistance here, and then the upper one for higher voltage, as the other person is explaining. Okay, are you all with me?
No. Yes.
Okay, great. So
Yeah,
let's
with you, sir.
proceed.
Now,
Yes.
we're going to plug the red probe into this V omega MA port. Now let's start with the relatively simple case of measuring the voltage of a battery. I'm going to set the dial on my multimeter up here somewhere in the V range. I'm not going to worry about the exact number yet. Turn the multimeter on, and again I have the black probe plugged into the COM port and the red probe
But
plugged
we
into
don't
the
hear
V
what the
omega
video
milliamp port.
says.
I have two batteries here, a AA and a 9-volt.
Sorry, you're
And
not
I'm going to start
hearing
out
the
with the
what?
AA. I'm going to take
The video,
oops,
it's odd.
the black probe and touch it to the negative side of the battery, and the red probe and touch it to the positive side of the battery.
Sorry. Okay. Well, I've paused it a bit. I've stopped the share. Were you saying that you are not hearing anything from the video?
Yes.
Yes, sir.
Oh, okay. Right. The hand is up. Yes, Vela? Viola, your hand is up. Viola Nabs, you wanted to say something? I'm not hearing you, Viola. Are you saying something? Your hand is right now when the learning is over. When you're putting hand up, I will assume you want to say something.
Sir, I'm not getting you at all.
You're not hearing me at all. Even now.
Sir, I'm not getting you.
Is everybody not hearing me?
Yeah.
We are
Yes.
hearing you, but the video.
The
We can
video
hear you.
is not
But we,
Get you.
Oh, it was the video you were not
we
hearing.
can hear you. Yes, but the video, the sound
Yeah.
in the video, we cannot hear it.
Okay. All right. Now I get. Yes, Jovia. Jovia, you're speaking. You're muted, but I can't. You're speaking. You're muted.
I wasn't hearing the video, but I was reading the words which are displayed.
You are reading the words. The audio was not. Okay, that means I didn't share audio. Let me see whether I can share with audio. All right, let me try and share again briefly. Okay, get back. Right, now it's going to be better. I can assure you that. Let's get to see what's up. It was this one. Okay, I want you to tell me if you can now hear. So here we go.
And you can see I'm getting a reading of 001 on the screen. And that's
Yes,
not a
we
very
can.
accurate reading. I'm not getting any decimal places. And you'll see that I have my knob set all the way up here to 1,000 volts, which, if you know anything about batteries, is much, much higher than we expect to get from a AA battery. We would expect this to be about 1.5 volts. So fancier multimeters will have an auto ranging feature where they will automatically select the measurement range for you. this multimeter isn't going to do that for you. You need to manually select the range that is the best for what you want to measure. So what I'm going to go do is go down a step to 200 volts and try again. And now I'm getting 1.5 volts, which is about what I expect, but 200 volts is still a lot bigger than what I need to measure. So I'm going to keep stepping down to the 20 volt range. And notice that when I do that, I get an extra decimal place. The decimal point moved over 1. So now if I measure, I get 1.6 volts, 1.60. So my reading is getting more accurate. I got an extra decimal place. This voltage is actually small enough that I can keep going down. Now notice that the label here changed. Now I'm in the 2000 M range, which stands for 2000 millivolts. So now my reading is in millivolts instead of volts. It's important to pay attention to the labels on the dial because they'll tell you the units of your measurement. Now here, I don't have a decimal place anymore. I'm getting 1608 millivolts. So as I keep going down, my reading keeps getting more and more accurate. If I go down too far, though, my range won't be high enough to measure the voltage. So I've gone all the way down to the 200 millivolt range. And now I'm getting a 1 with no other numbers, which is how this multimeter tells me that the reading is outside the current range I have selected. So if I go down too far, I'll get that 1 on the screen. I go back up to the next highest value, and that's going to give me my most accurate reading for this voltage. So in this case, I get 1,607 millivolts, or 1.607 volts.
Okay, let me pause there a bit. I hear some people are talking, so maybe somebody would like to ask. I see hands are up. Yes, Mayanja?
Sir, we've not been watching the video.
Are you sure?
Yes.
Yes, we have not been seeing it.
Yes.
Wow. Okay. Interesting. Everybody?
But some of us have seen the video.
Yeah.
Some of us have seen the video.
Yeah,
Yeah.
some of us have.
Because I really have shared, and I'm wondering why you are not seeing. Let me share again.
No, not all.
No. And it's like it's showing.
Are you seeing?
Yeah. Yeah, we
Yes.
see.
Is everybody seeing the screen?
Yeah.
Yes, sir.
Yeah.
Yes.
Okay, now if I play, just pay attention again one more time. It could be that some of you have network issues, so let's
I can do the same thing for the 9 volt battery here, where you might be able to guess if I have this set to 2000 millivolts, that's 2 volts. That range is
Are
not
you
high
seeing
enough, so
and
I get a
hearing?
1. If I want to measure that 9 volt battery, I'm going to need to go up the next step to 20 volts. And here you can see that this battery has actually been drained a little bit. I'm only getting about 7.98 volts instead of the 9 volts I would expect. Finally, if I reverse my probes, so if I put the red probe on the negative terminal and the black probe on the positive terminal, I will just get a negative number.
Great. I want to just pause this one here a bit. Do you see the negative on the screen? Hello?
Yes.
Are you
Yes,
seeing
sir.
negative? What's the value?
Yes, sir.
Negative 7.8.
Aha, negative 7.98. So here where it is explaining, when you see negative voltage, it means you have switched the terminals. You have put the positive probe, the red, to negative, and then the negative probe, which is the black, you have put it to positive. That's where you get a negative. So it's usually not a good idea to do that, but whenever by accident you see that, a negative value on the screen, it means you have interchanged the probes for the multimeter. So that's a very important thing that I thought you needed to see. Right. I paused it there just to be sure that we got that right. So back to...
So that doesn't damage anything, it doesn't hurt anything, that just tells you that you have your probes backwards because you would expect a positive voltage when measuring the battery. Now, measuring the voltage of a battery is pretty simple. What if we want to measure the voltage of something in a circuit? So here I have Now, what if I want to measure the current through this circuit? This gets a little more complicated. To measure the
Just a moment.
On this
Switching
port, we're
it
going
ahead.
to blow the fuse. So we can go all the way up to 10 amps on this one. Safer to start there, and we're going to turn our dial over to the 10 amp setting on the knob. So now I should be able to put my multimeter in series. You notice that the LED has gone out because I broke the circuit by moving that resistor. I put the multimeter in series here, the LED goes back on, but I'm getting a pretty inaccurate reading again. 0.01, I don't know what the decimal points are beyond that, so I should be safe now to move down to the port with the lower current range that's going to be more accurate. So I'm going to switch back down to here, lower myself to the 200 milliamp setting, and you can see now I'm getting a more accurate reading of 13.7, 13.8 milliamps. And just like I did with the voltage, I can keep stepping down to get more and more accurate readings until my range goes too low. So I can step down to 20 milliamps. Now I'm getting an extra decimal place, about 12.21, all the way down to 2000 milliamps, and now I've gone too low. Okay, so if I go back up to about 20 milliamps, that's going to be the most accurate reading I can get for this circuit with 2 decimal places. Now, when you are done measuring current, it is always a good idea to set your multimeter dial back to measuring voltage. And that's because it is much easier to accidentally blow the fuse when you have the multimeter set to measure current. For example, if you wanted to measure the voltage of a battery like we did earlier, and you connected the probes directly to the battery with no resistance in series to limit the current, while you have it set to measure current, you will easily blow the fuse because you're going to get a lot more than 500 milliamps directly out of the battery. So,
okay, another pause here. I want to just explain what he has just said, that whenever you are not using the multimeter, the best position to leave the dial on should be on voltage and not on the current side, because current, usually the elements are measured in series, so if you accidentally measure something that is very big, there is a chance that you can easily damage the device if, for example, the probe is on a lower current value and yet the current that passes through is very, 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 very high. So it's important to always switch the dial or the head of the pointer to be on voltage, because at least on voltage side the connections are in parallel, so there's always a resistor to absorb the high current. Okay, so I want to just leave this here for now. So that's how you work, you really use a multimeter. And all these others on the face here, as we saw, this is voltage, this is current, there are other units here, for example resistance that can be measured, and continuity down here. So all those are quantities that can be measured using a multimeter, and that's why its name is multimeter. So I'm going to just leave this here for now and get back. So I'll stop sharing. Right, Viola, your hand is up. You have a question?
I'm asking, is
Yes.
it possible that the next lecture, at least you give us a recap of what you have given us?
I haven't finished yet.
That is it possible?
We are still continuing.
That is it. At least for me, I've understood a little, but I didn't get it well. So is it possible in another lecture you explain more of it practically?
Yeah, we will see. We'll see as we proceed. Okay, is it Editor Ainaitwe? Your hand is up. You want to ask a question as well? Please go ahead.
Yeah, I'm seeing something like energizer. What is its use?
Oh, that was the battery. It was just being the batteries. The Energizer is a brand. He was demonstrating how you can measure the voltage of a battery whose brand is Energizer. That was what was being demonstrated in the use of the multimeter to measure voltage of a battery. So that Energizer was a battery. Is that okay?
Okay, thank you. Yeah.
All right, Kalunji.
Okay, my point is that, and in the first video, most of us editing any words. So when you started the video, you started it from the middle part, so we didn't get the other side of when it started. That's
Okay.
it.
All right. Yeah, but the beauty of this video is that it's on the LMS. So when you have registered, I'm hoping is Jennifer online? Unfortunately, I saw Jennifer was not feeling well. I don't know whether she has logged in. Is Jennifer online? I don't see her. Yes, but I can ask all of you. Did you give your email addresses? Did you register? Did you?
So,
Yes?
yeah.
Yes, sir.
Yes,
We registered. We registered.
Okay. Yeah, because I need to follow that up so that I see that you are on. So you are enrolled on the LMS in order to be able to get access to that resource. So that resource is on the LMS. That video, I've put it there. So at a time when you will be finally enrolled on workshop practice, you can listen to it again and follow it and from the beginning up to the end. Okay. Any other? Oh, Nathan, your hand is still up. You want to ask another question, or you forgot to lower? Yes, Nangobi, your microphone is flashing. Do you want to ask a question? Esther? Okay, all right, no more questions. Okay, so now I'm going to share just the handout. I'm going to share the handout just to quickly check what we have seen in the video, and thereafter I can conclude on that side. Okay. Right. Let me just get back to sharing. So I'm going to click share and my window. Right, next is all right, so are you seeing a PDF document now? Are you seeing a document?
Yeah, we can see it.
Yes.
Yeah, we can see it.
Good, that's what we are going to discuss. We shall be going through that document. Just highlight. I want to see the highlights again. Right here. So this is the multimeter that we're talking about. There's this one, the old type. The old type is which has a dial, a hand. So this one is called an avometer because it's mainly for measuring voltage and voltage, current, and resistance only. The three AVO. So AVO, amperes, voltage, and ohms, avometer. So that's this type, the old one, which has a dial. Then the one we are discussing is this one here, and there we will have an exercise. The next time we meet physically, that is probably next week. We'll meet physically again on Friday. No, on Wednesday. So when we meet physically on Wednesday, we will try and do this exercise. Use the multimeter to measure DC voltage. We will try and do that practically, and then we will also use it to check to measure, to check whether a cable, which is called IDE, I'll explain what that is when we meet, is whether it is broken or it is okay. That is called continuity. So we shall measure continuity, we shall measure voltage, and we shall measure current. So that's what we shall be using. So continuity, let me just explain it here so that when we meet, it's part one of the functions of a multimeter. is to see whether the cable is running from one end to another, it's not broken. Now, because some cables may look okay, but inside the conducting wires are normally inside, and when the conducting wire is inside, it is very difficult to know whether that cable is okay or it is broken. So normally continuity checks are set to read, to check whether the cable is straight, there is nothing broken, or there is something broken. Yeah, so that is what we mean by continuity. And normally we will set the reading to ohms, and then when it reads, when you check both ends, there is no reading on the multimeter, there is something else. When there is a reading somewhere, there is something else. So we will be looking at that when we meet physically. So that's a lab which we will only be able to do when we meet physically next week. Yeah, so I'll leave this here for now. For continuity and resistance, we shall measure this and then talk about the power also as well. Now I'm going to share another one. I'm going to share another screen, which is this one, and this is supposed to be our next topic, which is cabling, to talk about cables. Right, so before I go deeper into that, I want to pick whether you have any questions or comments. Do you have any questions? Oh, some people have dropped off. Let me admit them again. Right, Esther had dropped off. Now you're back. Okay, so any question, any comment before we start on the next one? The next topic we are going to deal with is cables. We're going to talk about cabling. So I want to see whether we are all now clear on, at least on tools, both the mechanical tools and the electrical tools, and then how the tools are used. Last time I talked about safety and the importance of safety, and safety with regard to the three areas: safety for self, that is for the user, and safety for equipment, the equipment that are in your workshop, and then safety for the environment. So I continue to dig and do research in that area of safety, so that we can when a time comes for some assessment, I will find out if you have done the right thing, or you have studied and looked at safety in regard to the three things that I have asked you to group everything under safety. We must, when you think about safety, think about the hazard. What is the danger that if you don't take precautions, damage can happen to you, the person, that's the self. Damage can also happen to equipment, and then damage to the environment. So look, those we call hazards. So look at the hazards. What are the hazards? And then what precautions, what steps do you take in order to minimize the hazards? So that is what I would like you to continue to read on and classify. Yeah, so that's where I wanted to just leave topic one. Sorry, Bakanya, you are talking. Do you want to say something to us? I assume that is Esther, although the name is called said Esatha. Esther, Bakanya, would you like to ask a question? Sorry? Okay, maybe Esther doesn't know that her microphone is on, so I'm going to mute her myself, and then yeah, so I can sometimes mute you, but I would like you to know how to do that, mute and unmute. So it's important. Now I've muted Esther. Sorry Esther, but I was not hearing what you're telling us. Okay, right, so let me now go back to what I have shared. I think I've already shared it. It's just a matter of tapping on it so we can see. Let me just get back. Are you all seeing the screen now? Cabling? Yes?
Yeah.
Yes, sir.
I'm hearing from this one, but mine is not talking.
Oh, somebody is, yes? One, I don't know, a number of people are talking. I don't know who is talking, whether they have issues. Wandera, any problem?
So I'm just joined.
Hello,
Wandera?
sir. I've just joined. I decided to join.
Oh, Fatima, you have just joined. Okay, you're welcome then. I had just indicated to people, shown them how they can join and how they can mute. So if you want to talk, you unmute. Simply tap on the microphone so you can unmute. And then I think Kevin, you're screening something to us. Akandwa now, Kevin, can you stop broadcasting your screen, please? Yes, Mayanja John Mary, do you have a question?
Yes, I'm not hearing.
You're not hearing, but I can hear you. You're not hearing me at all, but I can hear you.
Hello?
Yes, please.
I'm not hearing.
You are not hearing, but I am hearing you.
Yes?
I am hearing you. Okay, Mayanja, I can hear you. Wandera, I can hear you too.
I can't see my name.
Sorry?
Unmute.
Okay, Mayanja John Mary, I'm going to ask you to lower your hand now. And also Jovia, your hand is up again. Is there a problem? Nakiriza Jovia, your hand is up. You want to ask a question? There are two hands up. I see Mayanja John Mary and Jovia. Yes, go ahead and ask.
Me, I'm saying the letters are too small.
Come again?
Jovia.
Yes.
I'm saying the screen by the letters are too small.
The letters
are too small.
I have stopped sharing at the moment. That's why. But I'm going to put a full screen and you let me know whether they are still too small. Kalunji, Eric? Yes?
Excuse me, lecturer.
You have muted. Jovia, you have muted, so I can't hear you. Unmute and speak, yes?
Yeah.
No, I was saying that the letters are too small.
Okay. I'm wondering which letters you're talking about. I'm not broadcasting anything. Which letters? Can I go back to sharing and we see? Okay, this is the screen. Are you saying you can't see anything? Hello?
I'm saying that they are small.
Oh, okay. On which screen
I'm saying by the letters are small.
Are you using your phone?
Yes.
Okay, could it be your phone? Is everybody seeing very tiny letters? Let me hear from somebody else.
No.
Hello?
No, the letters are clear.
Yeah, actually I'm on 200. This is 200, this is 150. somebody is saying they can't see anything. Let me see, who is that who can't see anything? Julius Neon Saba, you can't see anything? Julius, you can't see anything? Wow. Okay. Julius sent a chat that they can't see anything. Julius, at the moment I've just stopped sharing. I wanted to be on just to be sure. I have stopped sharing, so I'm going to share again. At the moment I have stopped sharing. I want to ask. Oh, another hand is up. Yes, Jovia, what? Your hand is up again. Can you ask your question? And your screen, I'm seeing your videos also on. Jovia, your hand is up. Hello.
Yes.
I'm speaking to Jovia. Can you hear me, Nakiriza?
Yes, I can hear you.
Okay, so your hand is up. What would you like to ask me a question?
No.
So can you lower your hand, please? Yes, go to reactions, reactions, and tap on the reactions and tap on the hand so you can lower. Because when your hand is up, it tells me somebody wants to say something. So just go to reactions, click on reactions, and then you tap on your hand so that you can lower your hand. Okay, have you done that?
Yes, but I'm saying it's down.
On my side, I still see your hand up.
How come?
Okay, yes, tap on the reactions. Have you tapped on reactions?
Yes.
So now click on the hand again. Click it should show you lower hand. So you tap on lower hand. Okay?
I'm saying raised hand.
Whoa. You are saying raise, not lower. Okay, that means there is a challenge with the communication between your network and my network. There's a time lag probably, but yes. Okay, on my side I'm seeing that it is still, so I'm going to lower it for you on my side. Okay, so I have done that now on my side, so your hand is down. Okay, great. I see other people have joined us, so I'm going to share my screen again just to be sure. Those who are saying they were not seeing, so I have stopped sharing. I'm going to share again. Please try and especially Julius, and I don't know who was saying the words are very tiny, but it's a full screen, so it should be okay. So I'm going to just tap on that. So it's now a full screen. Are you seeing all the words?
Yeah, we are seeing.
Yes, you can see the words.
Can you read?
For the inconveniences.
It is okay. It's okay. Can you read? You read cabling there? Is it clear?
Yeah, it's clear.
Yes, it is clear.
Okay. So yes. So I'm going to just talk about one type of cable today only, and then we will pick it up from there on Wednesday. So when we talk about cabling, the essence, the reason why we are talking about cables in this particular the topic for you is to be able to know the cables which are required for doing networks, for building a network. So that's the essence of studying cables. So the skill we require out of you is that by the end of this module, you should be able to actually create two types of cables which are used for networking. The first cable is called a straight through, and the second one is called a crossover. But these cables are picked from a variety of types of cables. So before we go into those two, we need to know the types of cables. So we go through the history of cables. So the first type of cable, which is no longer really used, but it is still, it's no longer used for cabling, but at home you use it especially for connecting to your TV and the aerial, is called a coaxial cable. Okay, that's the first type of cable. So it's normally used now, which is used for cable TV. Let me highlight the word cable TV there. I've highlighted. Okay, do you see that I have highlighted the words for cable TV? Is it visible to you that it is highlighted? Yes?
Yes, it is visible.
Okay.
Yes, I can see.
Yes, sir.
Very good. Yeah, so that type of cable, coaxial, the name coax, it means somewhere there is axis. It comes from the word axis. That means there is an axis in the middle, but then surrounding this axis there are insulators. So this is how it looks like. So there is a connector in the middle, the copper wire. There is only one conducting wire which is at the center of the cable, and then this central axial wire is surrounded by 2 to 3 insulators, 2 to 3 insulating materials. Let me just get back to class. I see somebody is waiting in the lobby. Let me check who is waiting. Esther had gotten off again, so let me admit Esther back. Right, so in the middle we have the conducting wire. This conducting wire is made of copper. It is slightly hard, and you find it in the center. You find it in the center of the cable. Okay, so here it is. So in the middle, let me just make it more visible. So in the middle you have the copper wire, then a hard white core surrounding the wire is a hard insulating material, and then you've got a second insulating material which is normally sometimes looks like a sheath, aluminium sheath, and then finally the plastic cover on the outside. I'm sure many of you have seen that cable. The plastic cover is either, in most cases it is white or sometimes black. It runs from the aerial of your TV to the back of the TV, either directly to the TV or to a decoder. Have you ever seen that kind of cable practically in life, at home?
Yeah.
Yes. Okay, so that cable is referred to as a coaxial cable. It is called a coaxial cable. Right, so this is basically the schematics, the diagram, the diagrammatic representation. So there are two types. They come in two major types. Let me highlight the major there. I'm highlighting that. There are two types of coaxial cable. One is called thin net, and the other one is called thick net. So thin net, from the name suggests, look at the names. I want you to tell me something about the names. From the name, one is called thin net and another one is called thick net. So what would you just tell me, what is your understanding from these two names, thin net, thick net? Anybody would like to take that on? From the name, what does that suggest? Thin net, thick net, what will be the difference? Anyone would like to take a go? Thin net, thick net, somebody would like to ask to answer for me? Yes, Kakande?
Yes, I think the names they were named according to their sizes.
Go ahead. What about the sizes?
I think the thin net is a little smaller. It's smaller.
Okay.
Inside.
All right. Thank you, Kakande. Viola, your hand is up. Viola's typed her answer. She says one is light, one is thick. Viola, what do you mean by
one
light?
is light and the other is dark.
One is light, one is dark. Okay, that is Viola. Rukundo, your hand is up.
Thick net is more rigid compared to thin net.
Thick net is more rigid compared to thin net. Good answers. Nambi, Sandra.
Thin net has quite a small skin, while thick net has a big skin.
Big skin. Thin net, small skin. Thick net, big skin. Good. Wow, the answers are coming. Very interesting. Stella. Stella. Stella, I can't hear you. Unmute. Click on the microphone to unmute so you can speak. Stella. Okay, I cannot hear Stella.
The thickness is lighter and thickness is.
Okay, thick net is lighter and thin net is lighter and thick net is thicker according to Stella. Let me check the charts. Some people have also given their answers in the chart. Let me just check in the charts. Yes, in the chart I see Mayanja. Okay, Mayanja, those are, I had not seen these interesting comments from Mayanja. Mayanja, thank you. You're saying it's amazing, really. The village is out. Indeed, it is out. Thank you. Okay, Viola says one is light and the other one is thick or heavy. Okay. Jenny says thick net is more rigid than thin net. Absolutely true. Julia says, I think thin net is tiny compared to thick net. Good. Those are very good answers. So yeah, well done, everybody. I'll come back to the comments later, but those are very good comments. All right. I think Esther, you're having challenges. Bakanya is having challenges getting on. Sorry, Stella. Sorry, I'm tired.
And the thickness is not light.
Sorry, Stella, I have not got you. Come again. Try again. It was your line was breaking. Give it another try. Yes. Okay. Yeah, Stella, sorry, your network, I don't know whether it was breaking. I was not getting you very clearly. Are all of you hearing me? Let me just confirm. You're all hearing me clearly?
Yes.
Okay. Right.
Yes, sir, we can hear you.
Okay, thank you. I think Stella's network was not very good. But yeah, I love let's continue, and then let me go back to what I had shared. I hope it's still shared. Let me just click on okay, let me share again. Come back to our right. We are back here. So are we all here? Are we all visible? Great.
Yes, sir.
Okay, good. So as most of you have really given me the correct answers, Yes, the two types, as you can see already, thin net, the diameter in terms of inches is 0.25, thick net in terms of inches is 0.5. So already one is what? One is thicker than the other. So from the name thin net, it means it's thin. Thick net, it means it is thick. And the sizes are defined there, 0.25 and 0.5. That's a differentiation. So here I'm going to now give you very clear distinction. So when I ask you for three differences, you must tell me these differences, these three differences I'm going to explain, and that's where we're going to end. The differences between thick net and thin net. There are three major differences. One is in terms of rigidity. So thin net, thick net is in terms of rigidity. I think one person gave me an answer about rigidity, that one is rigid, the other one is not. So it is true, rigidity is one of them. One is more rigid, and the one which is more rigid is because of their thickness. So thin net is less rigid, thick net is more rigid. That is difference number one. Please take note of that. Then difference number two is in terms of the maximum cable length. When we talk about maximum cable length, it means the total length, the total distance over which when data is transmitted through the cable, it will be transmitted without any problems. So that is called the maximum cable length. Okay, before you can put a repeater or maybe a joint, the maximum length allowed for the cable to be able to transmit signals very well. For thin net, it is 185. Now if we are to give it to one whole number, or at least to one significant figure, normally we use 200. So 185 is exact. So 185 meters is the cable length maximum for thin net, while for thick net it can go all the way up to 500 meters. 500 meters. Are you together? Are you with me so far? I'm checking on you guys. Are you with me?
Yeah. Your voice is a little breaking. You don't know why?
Oh, I think it's a network problem now. But yes,
We are with you.
you are with me. Thank you. So it's 185 maximum length, and for thick net it is 500 meters. That's difference number two. So in terms of segment length. Then difference number three is in terms of the diameter. The diameter, of course, for thin net is 0.25 inches. For thick net, it is 0.5 inches. So those are the three main differences between a thin net and a thick net. However, with regard to speed, you can see here that both cables transmit data at the same speed, 10 Mbps. Mbps stands for megabits per second.
So we are not hearing.
You are not hearing me? Everybody?
We are hearing this, sir.
Okay, I think others have a network issue. Somebody's microphone is on and is giving us feedback. Please switch off. So I'm going to end with this one. I'm going to talk about the speed.
Some of us are hearing.
Okay, so network on the other people's side. So speed, the speed of data transmission for the two types of coaxial cables, thick net and thin net coaxial cables, both of them transmit data at the same speed, which is 10 Mbps. Mbps stands for megabits per second. Megabits per second, megabits per second. So that's the speed of data transmission. So I'm going to leave it here for now and just take comments, because we have about 15 minutes. I want to take the 15 minutes now for feedback, to get feedback from you. How was your feeling today? And then when we meet again, we will continue from here. So I want to leave it here with speed, the differentiation. It's about one, rigidity. Thin net is less rigid, thick net is more rigid. Cable length, thin net maximum length 185, and for thickness 500. In terms of diameter, which makes the size, so the diameter determines the size, bigger size. So the thickness, the size is bigger because its diameter is 0.5 inches, while thinness, it is smaller in size because its diameter is 0.25. The speed of transmission for both is the same. So that's where I will leave it for today. I want to end here and field some questions from you, and then I will call it a day. All right, so I see 3 hands. Julius, go first.
I'm inquiring, how do we get the hands out of the platform?
How do you do what?
How do we get the hands out?
Okay, you will only get the handout when you are enrolled. So when you log in, as I showed you the login procedure, when you log in and then you click on the let me just share my screen again on that to just explain the process. Let me stop sharing this one. Oh, Nambi is appreciating. I'm going to go to the comment shortly. Nambi, thank you for appreciating. Okay, I'm going to share my screen again and show you how you get there. So just bear with me for a second. So we go. I'm going to go. So let me just get the YouTube out. Okay, so follow me. Are you all seeing my screen right now?
Yeah.
Yes, sir, we can see.
Yes, sir.
Okay, this is the UICT website. I had shown you down here where my mouse is moving. There is the eCampus. I'll click on eCampus. Okay, are you all seeing the eCampus? Because I've already logged in.
Yes.
Okay, because I've already logged in, I am here. So my dashboard shows Computer Workshop Practice 1. So if you are enrolled, then you'll also be, once you log in, you'll see this, whatever course you are enrolled for. I showed you on I think it was on Wednesday. On Wednesday I showed you. So you'll see for me, mine, I'm teaching Computer Workshop Practice 1. I'm teaching Computer Hardware and Maintenance. I'm teaching Computer Workshop Practice 2. I'm also teaching Basics. So this is my dashboard. Now your dashboard will show the courses you are enrolled for. Right, so the courses you are enrolled for will be here, including Computer Workshop Practice. Once I get the list and I also know that you're already enrolled, I will then quickly enroll you to Workshop Practice. So all you need to do is click on Workshop Practice there, and then you will see the topics. Under every topic there's topic 1. You will see handout 1 here. That's mine, handout 1, the one on safety. You will see it there, then which includes everything about topic 1 and topic 2, okay, up to topic 3 with a video. This is the video that I had shared at the beginning of the lecture. This video is for topic 3. So once you log in, you'll click on this video and you'll be able to watch. Now handout on cabling is here. That is the second one, on cabling. So all you need to do is click on this, it will download. Is that clear?
Yes, sir, it is clear.
Yes, I think it was, sorry, I forgot the name again. So all you need to do is you click on there, you click on this handout on cabling, and you'll be able to download it on your phone, on your computer, and you'll be moving with it mobile. So it will help you, whether you're in the taxi, you can read on your phone. Okay? So that's how beautiful technology can make life, huh? Right. So back here. Okay, any other questions? Viola, your hand is up. Please go ahead. Viola Nabs. And also Naitwe Editor, you can also ask. I see your hand is up.
Yeah, sir, thanks for the lesson. But you left me from types of cabling.
I left you.
Yeah, that's yeah.
How did I leave you? You got you didn't understand?
Yes.
Okay. Let me just check. I'll check you. I'll get you back quickly. We only have 9 minutes. Let me take 2 more questions and then we'll just recap quickly. Kalunji Eric. Kalunji Eric, your hand is up. Eric. Oh, okay. Eric, you seem to have lowered your hand now. So maybe your question is not there. Right, Semwanga.
Yes, good evening to you. Thank you for the lecture. I'm just inquiring or requesting for a pardon on Mbps in full.
Okay.
It was somewhere about speed.
That's a speed, yes. Mbps stands for megabits per second. That is a unit for measuring speed of data transmission. Megabits per second. Mbps.
Okay.
Yes.
Thank you very much.
You are welcome. Okay, I think the hands are now all out. Let me see if there's any other hand. Okay, let me just get through the comments quickly. I see there are many comments in the chat. Oh, Enoch, there are people who are just joining now. Wow. Okay, when we are concluding, we are joining when we are concluding, but maybe you'll just hear our concluding remarks. All right, so just Wandera. Okay, so quick, let me just check the chart. Mbps in full, yes, it means megabits per second. I've already yes. Okay, so let me go to the comments. Comments are many. Oh, you're right, you had a lot of activity I didn't see. Does the avometer work the same way as the digital? Yes, it does. The only difference is that the avometer has got a mechanical hand. Viola's question, you will see a dial moving instead of the digits. So that's the difference. I think some of the comments earlier were about sorry, these were about not hearing, but that's now done. I think we have sorted that out. Okay, thickness smaller, we have answered those. Isaac, it's amazing, really, the village is out. All right, thank you guys for the good comments. You can hear. Okay. All right, somebody asked how about 10 base 5 and another one 10 base 2. Oh, okay, those I will explain next time we meet. I will explain the meanings of the 10 base 2, 10 base 5. Right, Nambisandra says it's really interesting, the lesson is very good, I personally am enjoying. Oh, good to hear that you have really enjoyed. Okay, that's nice. Okay, great. Right, let us somebody is saying, sir, there is this option of creating a new acronym. Is it helpful for you? Sorry, which one is that? I failed to get that. A new acronym. Sorry, that was Julius. I don't know, I am not following that, but okay. So let me say a quick thank you to all of you for turning up. Indeed, like Nambia said, thank you for turning up, and it is thank you. It's very great, and happy Easter. Julius, you're not hearing me now? Multimeter thing, we will check. Okay, any other comments, any questions, final remarks before I end the lecture? This is the time you can now talk. You can tell me, and we are here from you before I conclude. Yes, Mayanja, John, Mary, and Isaac. You, Mayanja first, and then Isaac.
Good evening, everyone.
Yes, good evening.
Thank you very much, sir, for the lecture.
Welcome.
Esther, unmute.
Yes. Mayanja, are you done?
No.
Go ahead. Conclude.
Thank you so much for this lecture.
You're welcome.
Though there have been some inconveniences, but I hope we shall be getting used with time.
Okay, that is true. You will.
Yeah, the village is really out now.
Yes, the village will go out slowly.
Yes.
But this was a very nice first step. So thank you, Mayanja. All right. Yes, Isaac. Isaac, your hand is up. 1 minute.
Yes, sir. Thank you very much. Now, I'm just requesting you, since we are not yet enrolled on the learner management system, I request that at least you download for us that handout and you send it to us in the WhatsApp group.
Okay.
Thank you.
All right. I thank you for that request. I'll see what I can do. Nangobi Esther. Esther Nangobi, your hand is up. And then Arinaitwe.
Yes, mine is the vote of thanks. Thank you very much for the lecture. We've really enjoyed.
You are welcome, Esther. I'm glad you have enjoyed. Yes, Arinaitwe.
Yeah, mine is a vote of thanks. We've really enjoyed. Thank you very much, sir.
You're welcome. I'm glad to hear that you have enjoyed the lecture. That is beautiful. So it's very encouraging. Okay. So I'm going to now stop the recording.